When we talk of parabolas, we are thinking about a double napped cone that's been intersected with a plane coming straight down. And the cross section, it looks like two parabolas looking at each other, but that's not necessarily the case. The two equations of each of these branches is not necessarily a parabola, each of them. So we have to consider them as different entities. With our ax squared plus bxy plus cy squared plus dx plus ey plus f equation, remember that that's the equation for any conic section. And if we're not rotating the conic, then b will be 0. So let's compare a and c. When we complete the square, we'll see one is positive and one is negative. If one is positive and one is negative, then we are going to see that the product of a and c will be less than 0. So look for one positive and one negative. That's the coefficient of x squared and the coefficient of y squared. The equation of, let's take horizontal orientation of a hyperbola first. The equation x minus h squared minus y minus k squared equals 1 is almost like the equation for a circle with radius 1, except now we have a minus. Notice a squared is always first and b squared is always second. With a hyperbola, a squared is always first and b squared is always second. So what matters, because we have subtraction, of course, 5 minus 4 is not the same as 4 minus 5. We don't have the commutative property of subtraction. So order matters. It's the order with the hyperbola. Whatever comes first is a squared. Remember, with the ellipse, it's whichever denominator is bigger was a squared. Now it's whichever comes first. Well, the verbiage is the same. If I find hk, remember to find hk, set x minus h equal to 0 and y minus k equals 0. Once you solve that little algebra problem, you'll find hk. If this is my hk, and I know I have a horizontal orientation because x is first, I still have the same definition. A is center to vertex. So if I go over A and over A, I have found the two vertices. Now, 2A is no longer called the major axis. I wish it was. It's called the transverse axis. And 2B is no longer called the minor axis. I wish it was. It's called the conjugate axis. Sorry, I've got the spelling wrong here. The conjugate axis and the transverse axis. That's 2A is transverse axis and 2B is conjugate axis. So I've just drawn the transverse axis. Well, one good thing that's similar to ellipses is that B remains perpendicular to A. So if I go over A, I'm going to go up B and down B and up B and down B. And now I've got the four corners of a box. So I can draw in, I'm going to actually do these like this. I've got my box, and through the corners of the box and the center, HK, I can draw asymptotes, and those will guide me in drawing my actual branches of the hyperbola. Now, what I'm going to do, I have horizontal orientation. I'm going to go along my asymptote and through my vertex and along my asymptote. Along my asymptote, through my vertex, and along my asymptote. So the hyperbola is actually just the purple part here. It is these two branches. Of course, it's not a function because it fails the vertical line test, as does an ellipse, by the way. Now, to find C, C remains the distance from center to focus and center to focus. So because C is the biggest, let's put it alone in the Pythagorean relationship, just as like it's a hypotenuse. A squared plus B squared equals C squared. There's the Pythagorean relationship we'll use to find out where C is. And once we find C, we can go plus from HK. Remember, that's HK. So we do H plus C. This would be H plus C. Sorry. This would be H plus C comma K, because I'm adding to the H point of HK. And this one here would be H minus C comma K. And that's how I would find that. When we consider the vertical orientation of a hyperbola, look, order matters. Y is first. A squared is always before B squared. A squared is always going to be found here, and B squared is always going to be found there. I know it makes some of you upset, but with a hyperbola, A can be smaller than B, or B can be smaller than A. Their size means nothing. Size doesn't matter. That only changes the slopes of our asymptotes. What really matters is which comes first. It's order that matters with a hyperbola. So if I'm just going to deal in the first quadrant here. If I find my HK here, now because A is under the Y, I'm going to go up A and down A to find my two vertices, and I'll go left and right B to find my box. And I make my corners of my box, and so I've got something that looks like this. Now I've gone left and right B here, and again I can draw the corners of the box through the center, gives me my two asymptotes. And again, I'm going to use A squared plus B squared equals C squared to find C. And from HK, I'll go up and down C. So this would be the point HK minus C, H comma K minus C, and here's H comma K plus C, because this distance is C. What I can tell you about the asymptotes now is that it's always going to be y equals rise over run. In this case, our rise over run is A over B, and then x minus h plus k. And here, if you get this right, you get this for free. Y equals negative A over B, x minus h plus k. Why A over B? Because that's rise over run. If we were doing a horizontal orientation, our rise over run, remember when we had horizontal orientation, we were going left and right A, and then up and down B. So if we have a horizontal orientation, you can see the slope now would be B over A. Do I memorize A over B or B over A? No, I just look at my picture. And I always know that center to vertex, be it horizontal or vertical, is A. So I think, okay, what is slope? It's rise over run. In this case, it's A over B for the slope. And if it's got a horizontal orientation for the hyperbola, then the slope will be B over A. But we're always going to say y is equal to slope times x minus h plus k. And you can leave it like that. You don't have to distribute and write it in y equals mx plus b unless you want to. It's not wrong if you do that. Either way is okay.